Okay, yesterday we stopped at alpha, beta, gamma. Make sure you go and look at all the example. Right. Today we go look into vector. We'll look into dot products. Right. Okay. So when you see the word Cartesian force analysis, we need to use IJ, K, IJ and K. So this one, let's say you have x-axis, y-axis, z-axis, and then there's a point A over here. How you put the A in coordinate system? How you write A coordinate? How you tell people that A is at here? How you write A, or you tell people that A is at there? So in coordinate system, you write A bracket. You still remember x and z. So what is x? 4 meter. Y is 2. Z is -6. Okay, so this is how you write the coordinate in 3-dimensional. All right. Okay, when you write this position, you always refer to a reference point. In this case, from 0 point. Okay, so this is how we write 4, 2, and it should be -6. Okay, it should be -6, not +6 in z-axis. So there's a typo error in my slides. Next, just now it's coordinate. Now we talk about vector. Morning. Right. Now you're already familiar with this diagram since our first class. So here you're seeing the blue color arrow pointing from O is the origin, to the point P. And when you see point P, there's a bracket X, Y, Z. That's what we explained just now. Then you have x-axis, y-axis, z-axis. And when you see this vector is unit vector. I cannot say unit vector. So this blue color arrow, you split into 3 axes, right? Previous class we stopped at alpha, beta, gamma. So you split this blue arrow into alpha, beta, gamma direction, blue arrow into x-axis, blue arrow into y-axis, blue arrow into z-axis. How you write the vector that you already split into x component, y component, z component? You xi, yj, and zk. Okay, x is the magnitude, I is the direction, y is the magnitude, z is the direction, z is the magnitude, k is the direction. So how you represent this blue color vector? Okay, how you represent this blue color direction? Okay, this blue color direction is the combination of these 3 arrows, xi, yi, and zi. Right? So when you want to tell people what is the direction of the resultant, you write as R. Okay, R is called position vector, means the direction of that particular vector. Where does it pointing to? We are talking about vector here. So vector have magnitude and direction. So this is the word we use, the word position vector. It just tell you the direction of the vector. The direction of vector, position. So if the question asks you, that normally you need this in your solution. When you see a question, normally you need to write what is R. So R in xi, yi, and zi. Can I? Okay. Any questions so far? Okay. All right. Now, can you not how this one is my notes. Okay. So this actually how you write the x, y, and z vector. It's just that you are adding all the tail together in one point. Then you split them into 3 directions. Okay. So you transform, you move around the vector. Now, for example, the left-hand side diagram into right-hand side diagram. You move this blue color. You split into 3. So you're moving the black color arrow become a vector diagram. So you maintain as x because this is the starting point, this is the end point. So you don't touch the blue color. Then you try to like mixing a Lego. You try to think, how do I move from this origin to this endpoint by using the black color arrow? You try to think like you're mixing, you're assembling a Lego bricks. So you don't touch the blue color. Then you have the losing piece, the x, y, and z. Then you try to think, how do I use this x, y, and z to reach from the origin to the endpoint P? You cannot change the arrowhead, but you need to assemble it so that it can reach point P. So you put x first, continue with the y, then continue with the z. Okay, you put the x first, then pull the y, assembly the z. These two diagrams actually meaning the same thing. It's the same thing. Okay. Can this one you understand? Stop me if you cannot catch up. Let me know. Okay. So when you're solving problem later, you'll be given this kind of presentation. You'll be given one blue color only. Then after you know where is the blue color, you need to split the blue color into x-axis, y-axis, and z-axis by using the alpha, gamma, beta equation that we learned previously. So if you forget, you just go back to the previous lecture. Then you write, today your additional homework is to try to assemble it like a Lego bricks. Stay the blue color, then join the losing part, the x, y, and z together, like the one you see on the screen here. Okay, we still at the position vector. So just now, this is a perfect case. Why I say perfect case? You start from the origin of the axis. What happened? Of course, in the real life, you cannot always pull your origin to somewhere, right? You cannot always say that, oh, I must start from here. So in the real case, the vector or the force, it can start from anywhere in the space. So let's say the one that you see on the screen here, you have position 1 to position B, A to B. So how you write or how you start your analysis? You start by writing the coordinate first. You write A, what is the coordinate on the 3-dimensional space? So A, you have your x coordinate, y coordinate, z coordinate. B, you have x coordinate, y coordinate, z coordinate. So you write the coordinate out. Okay, then the blue color is somewhere within the space with the direction. Okay, then only you fix where is your reference point. In this case, the reference point is somewhere here. This reference point can be moving, but we fix somewhere here, just for easy explanation. So when you have origin over here, expand your axis into x, y, and z, means your reference point. It's like open up your tripod. Okay, once you know the coordinate of A to B, then you expand your tripod x, y, and z. Then the next steps, first step, you write coordinate. Second one, you establish the x, y, z axis. Third one, you write the position vector for 0 to the A from the origin. From the origin to A, this position vector. How you write position vector? You write R sub A, which is from origin to A. It means if you write A, R sub A means to A, a position vector from reference point to A. Do the same for B. From the origin to B, you draw an arrow, then you write RB. So here you are seeing actually is a vector diagram. You should able to write the vector diagram equation, right? Something equal to something plus something. Are you able to write the equation? You know how to assembly this equation? What equal to what plus what? On the left hand side is what? Left hand side is your resultant. Resultant is from start to your final destination. Start to final. Which vector vector position it tell you the start to final. Huh? Which one? You understand what I'm asking, right? Understand that? You have three position vector here. R, RA, RB. Can you, this is a triangular vector. Can you write your equation for the vector equation? What equal to what plus what? R, what? Where is your starting point? Huh? Which one tell you, when you combine, which one tell you from start to end? Yeah, in this space is A is starting point lah. But we're referring to these three vector. Which, let's say I take away all this information. You only look at the vector. How you write the triangular? R, B. You understand? Okay. Let's say I give you this three vector. Which one is the resultant? Let's say I give you A, B, C. Which one is resultant? C, meh? This is start. This is end. Can you see these 2 points? So it's A. So this one is A equal this vector plus this vector. So the right hand side is how you reach the destination. This is how. This is what is your target. So start to end on the left hand side. This is how you reach the destination. It must be combined with the loss of action. Okay. On the left hand side, let's say Nilai to Penang. Right, Nilai to Penang lah. Nilai Penang. Then how you reach Nilai to Penang? You must go through Nilai, go through KL, then go to Penang. So here you write lo, Nilai, KL, Penang. So if you look at this diagram, without knowing where is the starting point, you look at only the vector diagram. Where is your, on the left hand side, where is your start and end? RB lah. RB equal to what? What comes first? R what? RA plus A plus R. So this is the basic understanding. When you look at vector, every time you form a triangular, you need to know how to write this form. This understanding is important. It will apply, I think, almost most of the engineering module. So when you understand this one, you can do lots of questions related to vector. So if you don't know what I'm talking about, then you need to flip back what is vector diagram. Okay. So again, triangular rules. Doesn't matter left hand side, right hand side. On the whiteboard, I write RB equal to RA plus R. On my slide, it's RA plus R equal to RB, remain the same, as long as you know what is on the left, what is on the right. Okay, important. This one important because if you don't understand how to write this one, you cannot do the question later. Especially we come to vector in the three-dimensional question. Maybe you're expert in 2D, but sure there will be a question ask you about three-dimensional one. So when question come out, then you cannot do already lah. 4 question, 2 will be 2D, 3 will be 3D. 2 2D, 2 3D. So 100 marks, you only can score 50 marks if you don't know vector. Then you repeat the module again. You resit and resit and resit lah. Okay, so don't start at vector chapter. So again, it depends. This is the following step. It depends what is missing in the question. Sometimes R is missing. So when R is missing, then you just move around the equation. Just rearrange lah. Important is you know how to write the triangular vector equation. That is more important. Okay, now in this case, if you rearrange, if the question asks you solving for R, means ask you to find R. So some of you, maybe your English is bad or weak. When you see the question solving for R, you jam already. Solving for R means you solve for R, finding the answer for R. So when the question asks you solving for R, you move RA to the right hand side. If you look at the slide, RB equal to RA. So again, what is RB? Now you look back at the diagram. What is RB? Assume origin is 0. Here coordinate here is 0, 0, 0. From the start of lecture today, I teach you how to write the position vector, right? So how to write RB? RB equal XBI, YBJ, ZBK. Okay? You should understand this. If you come in late, maybe you miss out this part. It just tell you how you form this direction. Okay? Means to form this vector, how many steps you need to move in X, how many steps you need to move in Y, how many steps you need to move in Z. So you write Xi plus YBJ plus ZBK. And of course, in a question, all this will be numbers. All this will be numbers, either numbers or you see the question will be like this. You see question something like this. So you need to know the position. Once you are given all this, is good. I suggest you write the coordinate out first. Because from the coordinate you can convert into I, J, and K in vector form. Okay. Since we only have 1 hour today, we will go very fast. RA, you should be able to write already. So what is RA? XA, I, YA, RJ, ZA, K. Run. What is the next steps? If you deal with vector, you group I together, Z together, K together. at the end, your answer will arrive at this form. Okay, so remember minus bracket means you bracket is good that you process the bracket means after you have negative in front, this one become negative, negative, negative. So you put xb minus xa, put as I, yb minus ya as j, zb minus za as k. Okay. In other meanings, is same as what I show you on the screen here. So this is from the real scenario in the question or in your daily work. Because maybe you need to pull a cable from one side to another side. Then you want to know how many force you need to pull that cable so that it becomes straight. Or the maximum force that you can do before the cable is break. So after you do analysis, you already know already. This is the direction, and you can actually see it as a box. Okay, when you draw as a box, actually, how you move from here, A to B, is you move from A to this direction. This is the X moving direction. This is the Y differences. This is the Z differences. Okay. So similar things like this. So position vector, when you lift up something, there's a connection cable there. There's a position cable in this one. Position vector is from A to B. There's a R there. Then there is a unit vector in that direction, for example. Okay. Okay. Now again, how to calculate unit vector? Unit vector, you take vector divided by magnitude. Okay, unit vector, you take R, you just remember unit vector equal to vector divided by the magnitude. How to find magnitude? Square plus square plus square, square root. Okay. Okay. Now this is another application of what you see. Just now you see a blue arrow, in the empty space 3 x, y, z. This is the application in daily life. So when you solve a question, you will see something like this. A cable mount to something, a point, then pull by a force. Okay, and the force is acting along the cable. Okay, so if you see a force pulling from a cable, this force is acting along the cable. Don't shift your force to somewhere else. Okay, you follow the cable, then you draw, and then you follow lah. Then there's a unit vector there. This is the direction, the unit vector. R is the position vector. Don't confuse between the R and U. Okay, R is the position vector. Where do you pointing to? F is the forces. U is a unit vector that is moving this direction. Okay, so we want to formulate F in Cartesian vector. So vector, you still have magnitude and direction. Okay, so you have same direction and sense as position vector R directed, and so on. So common direction specified by unit vector U. Okay, don't be scared by this one. Don't be scared by this one. I want you to focus on the front. Again, F is a vector. Vector have magnitude and direction. Force vector, the capital F here. force equal to magnitude direction. Small the F without the capital font will be magnitude. U will be your direction. Okay. Now, when you see this one, or when you apply this formula, when you're seeing 3D problems or 3D question, and the question force you to use vector analysis, it forces you to use IJK, then only you use this one. Yeah. The previous class is all 2D, so 2D you can use scalar. You can split into X or Y. Okay. But if you see the question in 3D, you need to call out alpha, gamma, beta equation plus the next step, solving for force, you need to write force equal to direction, magnitude and direction. U is the direction of the force. This small f here, or f without capital font, this one is the magnitude of the force. We already know how to find magnitude already. Square your x, square your y, square your z, square root. This one. Don't worry about this equation. Don't worry. This one already derived just now. Okay. Important is you understand what is this. What is unit vector? Unit vector again, vector divided by magnitude. This one is R. Huh? Unit vector is linked with position vector. So starting from today, your diagram, previously you only see a force. Today onwards, you need to convert your F. You need to, F is normally given in the question. You need to add R and U in your diagram. If you're seeing 3D problems. What happens if you have a 2D problem? Can you still use Cartesian vector? Can. You remove the Z only. You only remove the Z. You don't have K. You only have I and J. Okay. Now, why we teach you this one is important, especially when if you plan to work overseas, especially in Germany, Europe country. They are heavily using vector in their analysis. Okay, and nowadays you already have a very powerful computer. So usually we will just put in the matrix formula in the program, then ask a program to solve for you. Your GPS chip, everything they are solving in IJK formula. Your phone GPS signal, all these things. So again, this is just to tell you application in daily life. The ship, you have a anchor or there's a rope there. So important, start from today. In your diagram, you copy the force. After copy force, please write R and U in your diagram. Why you need to write the R? You need the R to calculate the U. What is U? U equal to R divided by R. On the top is vector, below is magnitude of R. Yeah. We now focus on the forces first. Next chapter, chapter 3, I will teach you how to draw the object. Today you only focus on the forces. Okay. Now, just an illustration of what we learned. Example 13. You have a man try to pull a cord because maybe he want to do some billboards decoration or something, Christmas decoration. So he pulled the cable with 350 Newton. These numbers can be changed when it comes to test or what. Represent this force acting at the support A. It tells you where is the reference point already. At support A, as Cartesian vector and determine its direction. Here, don't confuse with the scalar. Direction here means it asks you, force you to write in IJK format. Okay. Sometimes, of course, the question in test won't be this simple. It will expand this one a little bit. It will guide you, like for example, it asks you to put in the IJK, or the question asks you to expand IJK into alpha, gamma, beta. Then you need to draw the diagram. Put in, tell me where is the alpha, gamma, and beta. Yeah. Again, don't forget the alpha, beta, gamma. Example 13, we just want to practice the IJK equation. But from the IJK, you can convert into alpha, beta, gamma. Means cos alpha, cos beta, cos gamma. Okay. Now A to B. A to B, when it's pool, how you draw the vector. Important is the vector first. Where does it pointing? Pointing to A like this, or pointing to B like this? Like this, okay, pointing to B, I need to explain this one because maybe in the class, some of you, when it comes to test, you will try to point out one. Okay, try to imagine like what happened if you are the rope. What do you feel, or something like that. Okay, first steps. You draw the axis first. Copy where is x, y, z. Origin is here, 0, 0. Target is from A. There's a A to B vector. So you draw x, y, z first in your working. Then put in, you can remove all the object already. You can remove all the object. Important is the force. So focus point will be A. Okay. Let's see if you're able to delete. The question, although here is origin, the question asks you to focus on A. So your XYZ axis, you pull up to A. So don't confuse by the question. So when you solve this kind of vector question, you need to know what question asks you. The question asks you on A. So you focus on A. So you put everything to A. You already know what is alpha, what is beta, what is gamma from the previous class. So if you stand at A, you know that cable is going down from A. Okay, so A to B, forces is 350, alpha, gamma, beta. Okay, so how to write the position vector A to B? You need what? Just now the diagram. From today, I keep mentioning you. When you draw diagram, start from today, what you need to write on your diagram? Force, after force, what you write? And another two things you need to write, right? What you need to write? Position vector R and U. What is U? Unit vector. Write R on the diagram. Okay. Of course, U later lah. U later. U later. There's a U here, but later. So can you write the R equation? I show you the first one first. Okay. Do you know how to write the R vector? R is pointing from A to B, right? So R is what? R is you tell the robot how to move, how many steps you move in X, how many steps you move in Y, how many steps you move in Z, so that it reach from A to B. You can only move in X, Y, Z. So you need to tell the robot move how many steps in X, then followed by Y, followed by Z to reach the destination. So what is R? I give you the first one already. R is 3. You move X. This is X. You move in X. Then Y. -2. Remember, positive, negative important. Remember to write IJK in answer. Then negative 6. Who don't understand why 6? Okay, nah? 7.5 minus 1.5. So you're only moving from here to here. Okay, you have the R already. I'll help you to find what? U. Okay. Okay. You need R and magnitude. You need vector and magnitude. So I don't need to explain to you already. So of course, in the working, if you forget to put in unit, I still give you correct. Only the final answer, please put in unit. For example, R, put the M behind with the bracket. Without the bracket, please write 3im minus 2jm minus 6km if you don't use the curly bracket. So you press calculator, you get the magnitude, right? So from these two, you can find the U. Means what? You take this one, divide this one. Okay. Okay, so this no note lah. So all this got marks one. You write U equal to R divided by magnitude, got marks one. General equation in this module have marks one. Okay, you substitute and solve, you get this answer. If you can put in fraction, put in fraction. If not, then you put in decimal place. If you put in decimal place, I think minimum 3 decimal place for accuracy. Don't put less than 3 decimals. If you divide, then you don't put less than 3 decimal place. So for this module, if you can put in fraction, put in fraction. If cannot, then put in 3 decimal place answer. Okay, so let's say you get already U already. Okay, once you have U, then write this equation. Standard operation. So I'll show you one example, the rest is same. Then maybe here and there, you need to work from the back to the front and so on. So force equal to a vector of F have magnitude and direction. You have a F magnitude, you have a direction of the F. So what is your F equation? Again, F you can split into X, Y, and Z also. Okay, in this case, F is a scalar, it's a magnitude. Magnitude don't have IJK. So this F is a scalar, it's a magnitude. So don't have IJK. IJK means direction. So 350 Newton. Remember to, again, if you forget to put Newton, I still give you correct. If you want to quick, you forget to put in Newton, I still give you correct. Then you put in the U. Then after you multiply these two components, you'll get the answer will be in vector form. Okay. Can follow. Any questions so far? Make sense? What about angle? Angle, you need to refer to the previous class slides, which is the cos alpha equal what? Cos beta equal what? Cos gamma equal this one. Okay. So I record this one. I record this one. So in this case, because your U is here, U is this one. So your U is what? Unit vector. This is unit vector equal, what is the magnitude of unit vector? 1. So A is 1. So the one that you see here, don't confuse with the magnitude. This is vector. This is this cos I. Some of you're not in the class one. You're listening to the video recording. Don't confuse the A. The A here is it depends. Here we're taking the unit vector. Unit vector A is 1. And the cos alpha is 7/7, for example. 3/7. Okay. Then you solve for the alpha. for unit vector, if you are using U to calculate this one, unit vector 1, unit vector 1, huh? Okay. But if you use F equal to F U, then this is F. Your air is a force magnitude. It depends on what you take and use. If you take unit vector, then A is 1. If you write F equal to FUA, then you need to replace A with F lah. F lah. Okay. But still, your cos alpha still this component. Cos alpha is this 3/7. Cos beta still -27. Cos gamma still -27. If you put side by side the equation, this one. Okay. In this case, I'm using unit vector. Okay. You repeat for beta gamma lah, as long as you understand the concept. Okay. This is your homework. You do calculation check. Beta is 107, gamma is 149. Okay. Example 14. Observe the way you solve, and then the value you can check the details. Now this is application where you have support for the roof. This one is the latest design. Nowadays you see all these in the buildings already, the walkway or any extended sunroof. They use this design. So a roof is supported by 2 cables, as shown in photo. If the cable exerted force, given a force, FAB means A to B. F sub AC means the force is pointing from A to C. There's a direction, it's a vector direction. On the wall hook as shown, determine the resultant force at A. Again, it asks you to focus on A. Express result as Cartesian vector. It forces you to use IJK. Okay. Now, again, don't panic when you see the photo. You just need to remember what you focus on. You focus on A. Once you focus on A, remove all the object. Then you're seeing the force. Yeah. The force, the procedure is in your mind. You should able to roughly draft the step first. You look at the question, then roughly you know what you need to do before you write the equation. First, draw the axis first. Okay. Focus on a point. In this case, focus point is A. Second steps is what? Or you can jump. You write force equal to force, vector force equal to force U something. Okay, this just to remind you, don't forget this one. Okay, this is a vector. It's vector. Okay. Then the third one, in your diagram, what you do? What you add in your diagram? Make sure you draw the force. You put in R. You put in U. In the diagram, put the vector of F, vector of R, vector of U. Number 4, solving. Solving for R and U. Solve R. Why we need solve R? We can get U. Why we need to solve U? We can find the angle alpha, beta, gamma. Then you assembly. The last steps, you assembly F equal to FU. You combine all the information. Force, vector force equal to magnitude of the force. and direction of the force will represent by the position vector u. Or unit vector u, sorry. And you must remember how you find u. U will be, how to calculate u? R and magnitude of R. R divided by magnitude of R. So basically these standard steps, these 5 steps will help you solve most of the question. Okay, you see how we solve. No matter how many forces you have, in this example, you have 2 forces. So the first step, you write the focus point A, draw the axis. Again, don't be confused by the question. Don't draw your point at the 0, 0 point here. Draw from A. You can copy. This is more expert already. Means we just now, example 13, we move our focus to A. Now we just copy the question and we solve accordingly. Now A, you have 2 line there, red line. Then I draw the graph for my position, so I don't forget. So you write FAB, FAC. Where's your point? Your diagram. Put in the interest point B, B, C. Right. So resultant force, you know how to do, right? You combine these 2 forces, then you get resultant. So if you don't know, recall the first chapter, first lecture. We learn about parallelogram law. You draw parallelogram, then you draw triangular. Same with this one. This direction, you move to here. You move your ruler, the FAB, move your ruler, draw. Here, move your ruler to this side, draw. Intersection, you will draw a parallelogram. Something like this. This one in lecture 1 or lecture 2 already teach you how to do the parallelogram already. Don't forget, it's continuing, you applying what you learn. Okay. So this is the expected direction. The blue color is your resultant. So from this diagram, you know how to assembly as a triangular vector, right? This is the A is your starting point. This is the end point, the blue color arrow. So you pull this one over here. You pull your FAC over here, or you put your FAB over here. Same. Okay. Then you, in your diagram, start to use resultant F sub R, sub capital R. Okay. So I remove my diagram. Okay. I put the side because I want to know the coordinate later to put into IJK coordinate. So resultant force of R, again, you should be able to see this red color equation already from the triangular vector diagram. FR equal to FAB plus FAC. Okay, how to reach this point to this point? You need to connect this black arrow with this black arrow. Okay. Then you expand into IJK already. Okay. So again, right in IJK, since the beginning, you know F is a vector equal to magnitude and direction. Always remember, start from today. Force vector equal to magnitude plus direction. FAB without the capital, without the bold, is magnitude. UAB is the unit vector for the force. Don't confuse the R and U. R to help you. R is a position vector, help you to calculate U. Don't write R here. If you write R here, wrong idea. Don't confuse between the R and U. U is a unit vector. R is a position vector. Okay. FAB magnitude is given in the question. So just put inside there. Unit vector, this is just for your illustration or for your sampling. How to calculate UB? Take R vector divided by magnitude vector. Okay. R vector, RAB. You know lah, RAB. If you look at the diagram, how to from A to B. RAB, you move 4 steps X. Maintain Z. Maintain Y. Move down Z. This is your RB. Okay. Magnitude, square this one, square this one, square this one. Square 4, square 0, square 4. So you might ask, Dr. Ang, in exam, if I don't write 0J, can or not? Can. I write here just to avoid careless mistakes. Because sometimes, you know lah, your own handwriting, sometimes your I will become J1. Okay. Then you substitute and solve. You'll get this one. You put in RB vector, put in here, magnitude put in here. You do the solving. So once you get your UAB, put inside here. F we already know 100. So multiply by the vector, by the unit vector. You get answer 70.7I plus 0J minus 0.7K Newton. Without J also can. But if you want to write plus 0J also correct. Okay, so I hope you can see the steps here. This is for AB only. Repeat the same for FAC. Okay, repeat the same steps. So this one I skip lah. The answer is there. You can check. Okay. If this question come out in your assignment, please do. Please write all these steps. You solve FAC equal to so and so. So when you have two vector, you know addition vector, right? You know how to do already. This one plus this one, I. 0J. Oh, sorry, typo error. This one should be J. 40J, not I. Typo error. Then this one plus this one, K. Okay. Okay. So this is how you do lah. Of course, this question do not go to ask you to find alpha, beta, gamma. It will be in your test and final exam. Because we don't want to take so much time explaining about the alpha, beta, gamma. We already assume you know how to do. Yeah. Okay, 15. Also, you observe. Same steps one. Step 1, draw axis. Step number 2, write F equal to FU. Step number 3, go to the diagram. Remember to add in R and U. Why we need to put R and U? We need to use the R to calculate U. U equal to R divided by magnitude R. Solve the question, then assembly the F equation. So the force in figure, look in hooks. Again, it forces you to use Cartesian vector analysis, I, J, and K. Yeah, so I go very fast. So you look at the force. You are given the coordinate in the gradient form, a small triangular. But don't panic. It's still the same as tangent sine cos concept, right? Or proportional concept. So the first step, you need to know where is your focus point. A in this case. So A in this case, go to the diagram, put in the R and U, then you calculate. Okay, focus point A. You in your diagram, this should be in your answer. You draw X, Y, Z, copy the axis, put in A and B, put in coordinate. Okay, A and B. This one, maybe I add one more point here lah. Draw axis, then coordinate lah. Okay, some of you don't need coordinate anymore. If you do more exercise, you don't need the coordinate anymore. You see, you already know how to write. So, okay. So I just add in the small arrow just to show you how many steps we move in X, how many steps we move in Y, how many steps we move in Z. Okay. Then you put RB, you put in R, U and R in the diagram. Again, don't confuse the U and R. Okay. Then you do your things. Okay, you do your things. You calculate the UB, find the RB first. Then you calculate the magnitude, substitute, you get your U. After that, you get your U. Write F equal to magnitude plus direction of the force, which is your UB. You substitute, multiply, then you get the final answer. Okay. What is the take-home notes or reminder? Be careful on the negative. If it's go down, it's negative. Go against the x-axis, it will be negative. Go against the y will be negative. That is the careless mistakes. The rest should be no issue. If you remember the 5 steps that I mentioned on the whiteboard. Okay, I hope you learned something today. There are some extra homework you want to do, you do. It's an option. There are extra homework. Now, what is the difference between the fundamental problems? Fundamental problems is just to polish up your the equation and all this. You see problems, problems they are very near to your test 1 and final exam kind of standard. Okay, so fundamental problems like your revision, your self-revision, you just want to exercise a little bit. But the problems will be very similar to your final exam standard or test 1 standard or test 2 standard. Okay, next lecture or next week, we'll do dot product already. We're a bit behind, but we try to lay the good foundation, then we go faster. Okay. Yeah.